In this class, I'm going to discuss about the queuing system. In our day-to-day life, we come across the queue. If we go to book the ticket in railway station, we have to stand in queue. If we go to any hospital, we have to stand in queue. So in every place in our day-to-day life, we come across the queuing system. So in this topic, the problem of interest is achieve a balance between the cost associated with long waiting or queue and cost associated with prevention of waiting in order to maximize the benefit. So when we are studying about queuing system, basically four things we should remember. So there are four characteristics of queuing system. There are four characteristics of queuing system. In the system, one is, so we can categorize in four ways. One is the input pattern. Input pattern, or we can say arrival pattern. How the customers are arriving and under which condition the queue will form. And the second one is the service mechanism. Or you can say service pattern. So here I want to say that these two things we will consider under cohesion process. So the arrival pattern and the service pattern is considered under cohesion process. The cohesion process. And fourth one is queue discipline. Fourth one is queue discipline. That means how the queue is forming and how the service is going to deliver. That means here you can say generally we see that in the queue whoever coming first they are getting service first. So there may be in this topic I am going to discuss about three types of queue discipline. One will be first come first serve. Okay, this is one type of queue discipline. Or in other word we can say FIFO, first in first out. And second one will be uh, last come first serve. Last come first serve. That means sometimes you say in the queue if some senior citizen or some ladies comes, then we prefer them to get the service first. So even though they are coming late, they will get the service first. So last come first serve. In other word, we can say it is LIFO, last in first out. And the third one is zero. Zero means service in random order. This one is nothing but service in random order. Service in random order. So basically in this topic I am going to discuss about these three type of queue discipline. So this is the third number, and the fourth one is and then we will management. Fourth one is we can manage the queue. But fourth one is the consequence of these three. So we are not going to discuss this one separately. So basically, I will discuss here three types of characteristics of queuing system. One is the input pattern and the service mechanism and the queue discipline. Out of these three, first two we will consider under poison process, arrival pattern and service pattern we will consider under poison process, and the queue discipline may be any one of them, first come first serve or last come first serve or zero service in random manner. So symbolically, how can we represent a queuing system? So symbolical representation of queuing model. So generally, the queuing model is written as generally the queuing model is represented as A slash B slash C colon B slash E. So these are the abbreviation where A is where A is nothing but the type of distribution of the number of arrival per unit time. So type of distribution of the number of arrivals per unit time of the number of arrivals per unit time okay, and as I said you, the arrival pattern is Markov process and we can denote it as by m. So a in this case is always m. Markovian process we will denote it as m. And similarly b is nothing but a type of distribution of service time. This is the type of distribution of service time, and we denote it as also m because as I told you, these two are a Markovian process. We will consider these two as Markovian process. And what is c? C is nothing but number of servers. C is nothing but number of servers. How many servers are there to give service to the customers? And D will be nothing but capacity of the system. Capacity of the system. That means how many customers can be accommodated in the system. Where there are servers, it will have a system. In that system, how many customer can be accommodated. And finally, E is nothing but queue discipline. E is nothing but queue discipline. Okay. So suppose I will write here, for example, what I write M1, and I can say that infinitive and FIFO. So how can I read it? It is here C is D is capacity of the system. So D is nothing but infinity. That means the capacity of the system is infinity. Whoever come, they can able to join the queue. And C is nothing but number of servers. So how many servers are there? One. And the queue discipline is nothing but fast in and fast out. So this symbol can be written as single server infinite capacity model. So this I can say single server infinite capacity. Infinite capacity model with the queue discipline with the queue discipline fast in and fast. So like that we can these two are always fixed in this case because arrival pattern and service patterns are Markovian. So mm will be there in place of a and b, and c will be the number of server. Whatever server will be number there will be whatever number will be there, we will name the model accordingly. Okay, suppose I will write like this: mm1 and then I will write here k FIFO. That means single server. This k is finite, not infinite. So I can say this one is single server finite capacity, finite capacity queuing system, queuing model. So here basically we are considering fast in, fast out in our topic. So like that we can able to symbolize the queuing model.